This lesson we're going to be talking about vertical and horizontal asymptotes. Finding the vertical asymptotes of f of x is going to be what we talk about first. Here's our function f of x is equal to 1 over x minus 1. So when we're looking for vertical asymptotes, it's going to be important that we look into the denominator first. We want to focus on the denominator. So set the denominator equal to 0. And once we set the denominator equal to 0, solve for x. Well, we can see here simply that if I plug 1 in, I get 0 in the denominator. Well, this means that we have a vertical asymptote at x equals 1. And here's the graph of the function, and as you can see here, I indicate with this dotted line, this vertical dotted line, that there is a asymptote at x equals 1, and we set that asymptote. We just simply write out this equation right here. Okay, our next function we're going to look at, we see that there's a vertical asymptote and a missing point. So we're given the function f of x, and we want to find any vertical asymptotes that exist. We want to set the denominator equal to 0 and solve for x. And so I do that here. This one here factors nicely. So we set each factor equal to 0, solve for x. So we can see that this one here becomes x equals 1 and x is equal to negative 1. If x is equal to 1, then we get 0 in the numerator and denominator. And as you can see here, as I rewrote it, the denominator factored. If we plug 1 in, the 1 in for x in the top, we get 0, and we'd get 0 in the bottom. Now this means that there's a hole in the graph. I should actually say just because we get 0 on the top and 0 on the bottom doesn't mean for every time we get a hole in the graph, but usually most of the time there's a hole in the graph. But anyway, okay, so we cancel these two terms out, and now we have simplified it, and we get a new function. Now this function is actually equal to this function as long as I state that x cannot be equal to 1. Now as you can see here, if I plug negative 1 in the denominator, we get 0. And 1 over 0 now means that we have a vertical asymptote. But there's a hole in the graph at x equals 1 and a vertical asymptote at x equals negative 1. Okay, let's look at horizontal asymptotes. We have got three possibilities when it comes to finding horizontal asymptotes of a function. And let's take a look at these possibilities. Okay, the three possibilities are either y is going to equal to 0, y is going to equal to a real number, I've got a as an element of r, or no horizontal asymptote at all. So we're looking at a function here, f of x, which is equal to x over x squared plus 2x plus 1. I'm saying that the horizontal asymptote is y is equal to 0. So here's the pattern that we want to look at. You take the term in the bottom that has the largest exponent, which happens to be x squared, and then we look at the term in the top, which the only term in the top is x, and we notice that it's just to the first power. Well, since the term in the bottom with the largest exponent is larger than the term in the top with its exponent, see, we're comparing 1 and 2. Since it's larger in the bottom, then y is equal to 0. Here's another example, right? Larger in the bottom, even though there's no x's in the top, this is still going to be y is equal to 0. Now as you can see in this particular problem, we have an x squared in the top, x squared in the bottom. You just look at their coefficients, 4 over 7. So we end up with 4 over 7. Okay, looking at another example here, we have x to the 5th and an x to the 5th in the bottom. And that means that we look at the coefficients, 9 over 1 and 9 over 1 is 9. So these are both the same. So this was bigger in the bottom than in the top. Then we said it was y is equal to 0, and if they're both the same, then you just look at their coefficients.